Now that you know the basic layers of the skin from the epidermis, the dermis, and the subcutaneous layer, let's talk about the specific layers of the epidermis, and then also along with that will be growth of those layers and repair of the skin. So here are the layers of the epidermis. So remember before we were looking down across an entire section down. This here is the dermis. We looked at the two layers of the dermis and the subcutaneous layer. Right now we're focused in, zoomed in to just the epidermis and then also the very top of the dermis here. These are called dermal papilla, these things here. I want to mostly focus on the left side here, which is a real histology picture of from a microscope of the layers. Over on this side, we've got lots of other important, a lot of accessory structures that we'll come back to in a later video. So the layers of the epidermis go from the stratum corneum. Corneum is a horny layer. This is the very surface of your skin, down to the stratum basilae. That is the base layer where there are stem cells that are actively dividing, going through mitosis in order to create new skin cells. So in between there are a few other layers. So there is stratum basilae down here. These melanocytes are special cells we'll come back to in a later video. The stratum spinosum is above that. Then we've got the stratum granulosum. This is a very granular layer. So the cells here are producing a lot of keratin, which is the protein that is waterproof and is very protective for the surface of your skin. So this is where the cells start to produce a lot of keratin, and they also start to die. So it's kind of like going from down here, dividing cells, to dying cells. Up here, then we've got dead cells. So there's two more layers here. The stratum lucidum is a very clear layer that's just in between the granulosum and the corneum. The stratum corneum is made up of dead cells that are designed to just be protective. Remember, this is stratified squamous epithelium, and specifically it's keratinized stratified squamous epithelium. What that means is not only is it stratified squamous, just like the esophagus, it also is keratinized. So these keratinocytes are cells that produce keratin, are producing a bunch of keratin. And this then kind of over here shows a little bit more of those labels. So at the top here, we've got exfoliating cells that can fall off. They're dead. We've got dead keratinocytes here. Here they're living. They're producing a lot of keratin down here. Down here, there's stem cells going through mitosis. That's that basilar, so basilae is a basilar base level, are the cells down here. The other components in this image, I'll come back to some of them. So tactile cells, melanocytes are and sweat ducts and pores that I'll come back to in a later video. So I want to show you the same image in a view that you'll see in lab. So this is the slide that we have for lab. And you see it looks a little different. This is thick skin still. This is a fingertip. And I just want to show you, walk through these layers on this image as well. So ignore this picture on the right for now. Over on this picture on the left, can you label the layers that are shown here? Starting with the deepest layer. This would be the adipose tissue. So adipose tissue down here, that's that subcutaneous or hypodermis. Then we've got the reticular layer of the dermis. This is dense irregular tissue. Above that, we've got our papillary layer of the dermis, which is areolar tissue. That includes those papillary derma there. Then above that, we're going to get into the epidermis. So from here, right about here to here, that is all epidermis. And actually, I could go ahead and indicate that here. Boop, boop. Epidermis is what we're focused on here. So for the epidermis, we are going to first label that base layer, the stratum basilae, and that is right down here, not super apparent from this view. That's where mitosis is occurring. Then as we go to the next layer, I want to jump over to this image because this is a zoomed in piece of this that starts basically the layer just below the stratum granulosum. That's the stratum spinosum. So we've got the stratum spinosum there. We've got the stratum granulosa producing a whole lot of keratin, and that is visible there in granulosa. Above that, we've got the stratum lucidium, that clear layer that's pretty thick on these sections. And then above that, we've got the stratum corneum. I want to go over and show that over here again as well, because that's actually a very thick layer for thick skin, very protective. So I mentioned this already, but let's talk a little bit about skin growth. What I want to do is actually, since I already kind of walked through this, I want to go ahead and show this video that I have right here. It's a really nice diagram of this. Let's be as visual of the process. Just two things that he mentioned that I want to say. He talked about these the basal cells being cuboidal. You can kind of see that here, and they are. However, this is still called stratified squamous epithelium because it's based in the entire set of layers. We don't give two different names to this type of epithelium. So overall, this is considered stratified squamous epithelium, even though some of the cells, it's variable throughout the section. The other thing he said was talking about the tight interlocking junctions. Those are the tight junctions that lock epithelial cells close to each other often. Just want to remind you of that term, tight junctions. Okay. Something that's interesting about this is, so from here down, you've got a turnover every few weeks of your entire epidermis, right? So one thing that's kind of cool to think about is if you're going to get a tattoo, what layer do you think that has to go to for it to be permanent? Well, it's got to go below that epidermis. Tattoos must penetrate below that basement membrane here on this diagram. Here's your basement membrane that connects the epithelial layer to the areolar tissue. And so it's well within the dermis that tattoos have to penetrate in order to be permanent. Okay, let's do a quick learning check here. Which of the following epithelial cells have the highest rate of cell division? Hopefully you know this one. It's the keratinocytes that are in the stratum basale. That base layer there is where there are stem cells that are still able to divide. Okay, one last topic for this video is tissue repair. So what I want to show you here is that if you penetrate through that dermis, the process of tissue repair is a little bit more complex than it is if it's just in the epidermis. So remember that epithelial tissue is avascular. So if you penetrate, just get a surface scrape just of the epithelium, you're actually not going to bleed. So a lot of the injuries we get actually do go into the dermis. That's still okay. Our bodies have ways of dealing with this. So what happens is here's your penetration into the dermis. And the first thing that happens is an immune response. So various white blood cells are recruited to the site. This is partly due to inflammatory cytokines, which are chemicals that promote inflammation. You know, inflammation means it gets hot and a little bit red, and a little bit of that's okay. That's your immune response, and that's going to also result in blood clotting. So platelets come and clot or stop that wound from bleeding. That's a good thing. After that, you've got regeneration. So long-term healing occurs. The epithelium regenerates, starting with the basal layer, right? That's where we have mitosis occurring. So it's going to start there and go up. You also have to repair the dermis. So the dermis is not composed of epithelial tissue. It's composed of fibroblasts that make collagen fibers. So you have this granulation tissue that is scar tissue made of collagen fibers. Remember, this dermis down here is made up of areolar at the top and then dense, irregular connective tissue below that. When you had the scar tissue come in, the collagen fibers come in fairly parallel in order to repair. So that's what actually a scar tissue is. It's the parallel collagen fibers that look a little different than your typical skin. And this obviously varies depending on the size of the injury. That's why you can have this scar down here, scar tissue in there, is those collagen fibers are a bit more parallel because of how they healed. You can actually see that here with this last one is permanent repair. There's a little bit of area that's fibrosed. So that's just collagen parallel fibers that are not really what was there beforehand. And the epithelium here regenerates fairly normally. So when does an injury leave a scar? When it punctures the dermis. So that's when it's able to. If it just punctures the epithelium, you're not going to have a scar because those cells are always regenerating anyways. Puncturing to the dermis is not something that happens without probably having some amount of scar tissue occur. So in these two learning outcomes here, one was describe skin growth, so the life cycle of keratinocytes from the stratum basale to the stratum corneum. So this learning outcome involves knowing those layers, which you'll also see in lab, as well as talking about a little bit what happens in those different layers. So that where mitosis occurs and then where keratin is being produced. Second one is describe the role of inflammation and regeneration in response to tissue injury, and contrasting injury to the epidermis to the dermis in terms of scar tissue and the repair that occurs.